x minus p squared is 0. Agree or not? The minimum value for this expression, x minus p, is 0 for any value of x. If x is a member of real number. Agree or not? Do you agree with me?
Yes.
Yes. So a square number is always positive. This is because any number you square it definitely is greater than or equal to 0, right? Okay, so this is the facts that you know. So now from this, if I write my quadratic equation in this form, so what is the first thing I can extract from here? If A is greater than 0, so the curve will be of this shape. Correct? Am I right? So therefore, the minimum value for y is what? What is the minimum value for y? Q. And it happens when x minus p square equal to 0. Am I right?
Yes.
So that means my x is equal to p. So therefore, from here, the minimum point is the x coordinate is p, the y coordinate is q. Am I right? So if I write my quadratic equation in this form, I can straight away know what is the coordinates of the turning point. Agree with me?
Yes.
Yes.
Yeah. So if A less than 0, so the curve will be concave. So there is a maximum point, right? So therefore, the maximum value of y is also q when x minus p equal to 0, correct? So p equal to negative, x equal to p. That will be the coordinate. Hello? What? Shafiq? Shafiq Johari?
I'm sorry, no, nothing.
Why nothing then? You are not supposed to talk to anyone when you are having a class. So the maximum point, the coordinate is PQ. So that is the advantage of writing this in a completing the square form. So if I want you to know the coordinates of the turning point straight away for a quadratic function, I will present my quadratic function in this form. I will not present my quadratic function in the general form. Are you okay? So that is the good thing about presenting your quadratic function in a completing the square form, so that the person who read it straight away know that whether the maximum value or minimum value of that function. Agree with me?
Yes.
So now if, for example, I give you this example. Okay, I say given y is equal to 3, take away 4 into 2x minus 5 squared. Okay, so part A, I say state the maximum value of y. Do you think you can? Do you think you can? Can you tell me the answer? Okay. So this is your Q. Am I right? So the answer is 3. So maximum value of so you can straight away know. Okay. Then if part B, I ask you, state the axis of symmetry. Can you?
5/2.
Okay, 5/2. How do you get that? So we know that this curve should be this way. So allow me to explain. Okay, allow me to explain. The curve is this way, am I right?
Yes, yes.
So this is the point whereby the y coordinate is 3. The x coordinate is 2x minus 5 equal to 0. Am I right? So 2x equal to 5. So x equal to 5/2. So this is 5/2. So this is the axis of symmetry. So therefore, the axis of symmetry is x equal to 5/2. That is also the x coordinate of the turning point. Now, if I ask you part C, find the x-intercept and y-intercept. So this one, can you see it straight away? The answer is no. So how to find the x-intercept and the y-intercept? So now to find the x-intercept, what do? We sub y equal to 0, correct? So we have this 0 equal to 3 minus 4, 2x minus 5 squared. Okay, how to solve this? Are we going to expand the thing? Can I have a point of view? Do we need to expand?
No.
Correct. You're right. We don't have to expand. because we can write it in this way. Okay, so we take the square root. So we have 2x minus 5 is equal to square root of 3 over 2, or 2x minus 5 is equal to negative square root of 3 over 2, correct? Are you okay?
It's
Yes.
supposed to be 3 over 4
Hey, why 3 over 4?
from.
Why 3 over 4? You look carefully. I have taken the square
Alright.
root.
Okay.
Am I right?
Yes.
Okay. So therefore, the exact value for the x-intercept will be square root of 3 over 2 plus 5 divided by 2. And the other one will be negative square root of 3 over 2 plus 5 divided by 2. So this is the exact value, and you can simplify it further. Okay, to get the y-intercept, you sub the x equal to 0. So the y-intercept will be okay, 3 minus 4 times negative 5 squared. Correct? So that will be negative 97. Am I right? So if I write in a completing the square form, this form, then if you want to find the x-intercept and the y-intercept, then you have to work on it. You can't just look from that. So the good thing about this is you straight away can know the maximum or minimum value of that quadratic function. Okay? Any question before I go further?
No.
No, huh? Okay, now, if I give you a quadratic function in the completing the square form, I also straight away can know whether that graph will cut the x-axis or not. Okay, so I'm going to give you 4 examples. You tell me which one will cut the x-axis, which one will touch the x-axis, which one will not touch or cut the x-axis. Okay? So think about that. That means which one have 2 x-intercept, which one have 1 x-intercept, which one have no x-intercept. Okay? Number 1. Number 2. Number 3. Number 4. Number 5. Okay. Tell me which one will cut the x-axis, which one will touch the x-axis, which one without x-intercept. Okay, I give you 2 minutes to think about it. In this case, I don't have to use b squared minus 4ac. Okay, done. Okay, number 1, who want to try? Is the function, the graph for this function, quadratic function, cut the x-axis? Does the graph for this quadratic function cut the x-axis?
No.
No. Okay, how do you know? No.
Minimum point is 5.
Okay, that is not minimum. You don't call minimum point. You call minimum value. So, if I say the minimum value, for y is 5, correct? From here, I can straight away tell you the minimum value for y is 5, which means that if the function, the domain, that means my possible value for x is x and any real value for x. So what will my range be? Can someone tell me? Can someone tell me? What will the range be?
Y greater or equal to 5.
Yeah, y will be greater than or equal to 5. That means my graph will be this way. The value of y is 5 onward, correct? So straight away, I know that there is no x-intercept. Right? Okay, that is how we look at it. Okay, how about number 2? And how do you know that is a minimum value? Is because a is equal to 3, which is greater than 0. The shape of the graph is like that. Okay, how about number 2? Does the graph cut the x-axis?
Yes.
Yes. Okay, Kristen, can you explain to me? Your friend say yes. Can you explain to me? Hello?
Not quite sure, miss.
What do you mean by not quite sure? First, you have to look at the shape of the graph first. How can you say not quite sure? I say the shape of the graph very important. This is a maximum, a concave or convex?
A concave.
Concave. So you have a maximum value, correct?
Yep.
So what is the maximum value?
3.
3. Okay. So A, so that is how we analyze. So there's a lot of thinking going on. So A is -1. So the shape of the curve is like that. And we know that maximum value of Y is 3. So the graph and here is 4, 3. So you got, if it's a maximum curve and the maximum, that means the range. If the domain X is the member of real number, so the range will be Y is a member of real number and Y is less than or equal to 3. So it does cut the x-axis and there is an x-intercept. So if it's a maximum curve and the maximum value is positive, then it cuts. Are you okay?
Yeah. Okay.
Yeah. So how about number 3 then? Number 3. Cut, touch, or no? X-axis I'm referring to. No one want to answer, then I pick the name.
Touch.
Touch. How you know it touch?
Minimum
Research.
value is 0.
Yeah, because there's here. Y equal to 5 minus X. So the coefficient is 1. So there is a +0 here. So therefore, the minimum value of Y is 0. Right? So the graph go in this way. Here is your 5, 0. Agree? Okay, so the range I'm not going to write. So how about number 4? So after a few, you should be able to do, correct? Okay. Jia Hao. Jen Hao. Lao Jen Hao.
Yes.
Yeah, Jen Hao.
It does not touch.
It doesn't touch. Okay,
Yeah.
why?
The maximum.
Okay, it doesn't touch, but does it cut?
No.
No. Okay, why?
The maximum value is 36.
Yeah, so the maximum value.
And the shape is concave.
Yeah, you are right.
Yay.
So you see, you need to learn how to analyze. You are 17, 18 years old already. So maximum value of Y is -6. So when you want to do max, you want to be able to solve the problem, you have to know which one to look at. So, and A is -½ So the graph is so. If you imagine like that, all these, then the graph go in this way. Is my graph correct?
Yeah.
Jane, how sure?
They,
Look carefully. I purposely make mistake one. I know I made mistake already. I purposely draw also. What is the axis of symmetry for number 4?
One
Someone-
1/3.
1/3. How you get 1/3? May I know, young man?
The 3x minus 1 bracket square equals 0.
Where got 3x? Young man.
Oh,
number
wait,
4.
never mind. Oh, okay.
Number 4. Number 4.
Oh, it's x plus 3 equals 0, then it's negative 3.
Yeah. X plus 3 equal to 0. So x equal to negative 3. So Miss Do graph correct or wrong? Wrong. My axis of symmetry is at the positive region. How can? So you better pay attention in class. Your teacher very good in making mistake. So the graph go in this way. The axis of symmetry is here. X equal to negative 3. Are you clear?
Yes.
Okay. So let's go to number 5. So you see, if you write in a completing square form, correct, it's very easy for you to sketch the graph. Yep. Okay, number 5. How about this curve? Does it cut the x-axis? Yes or no? Okay, let me call another person. Who is that? Who is the Sebas 756728?
It's me.
Sebas. Sebas.
Yes.
Yeah, why you put such a that one?
Huh? Oh, I don't know. I have no
you
clue.
don't know. You have no clue. You are the one who put, you say you have no clue. How can? Okay, so number 5.
It has 2 intersections.
2x intersect. Why?
Yeah. Because the minimum point is -8.
Yeah, a minimum point again.
Sorry, the minimum value.
Yes. A is equal to 5/2. So the curve is, so the minimum value of who? Value of x or value of y?
Why?
Is -8. So if it's negative, then definitely the graph will cut. Right? It will cut. Yep. So this is 1/3 and -8. Is my axis of symmetry correct? Is my x coordinate of the turning point correct? Sebastian,
Yes.
correct?
Yes.
Sure.
Yeah.
Not 1.
What?
Not 1. It's 1/3.
Yeah, it's 1/3.
How you get 1/3? May I know?
3x minus 1 square equals 0. Then you can solve for the x.
Thank you. Okay. So you see, when you write in a completing the square form, that is the purpose. So if I want people to know exactly how is the graph look like, and I want people to know what is the maximum value of the function or minimum value of a quadratic function, I present my quadratic function in this form. I won't present it in a general form, because that will make the reader have to take some calculation to interpret the thing. So when you present your report or anything, you will make the reader do as little as possible, especially max calculation, especially max report. Yeah, one look. Oh, yeah. So I can analyze. So the person must understand max as well, correct? Okay, now, are you okay so far? So every form of function, the way we present a function, there is a purpose. Okay. So now, if I give you a quadratic curve like that, now I give you a quadratic curve. Okay. So I want you to find the function for this, for quadratic curve. Okay, so I said the shape is parabola. Okay, I ask you to find the equation of, find the expression, or I cannot say expression, I should say find the function fx. Find the function fx, or find the fx function. Okay, do you know how to find? So when I say find the function fx, so function fx, quadratic function, when you have this word parabola, that means I straight away tell myself fx can be written in this form, or fx can be written in this form. Correct? So I have two forms. So which one are you going to choose to solve this problem?
It's the bx square.
Ax squared plus, plus bx. Plus bx, okay, sorry. A cannot be 0, understood? Okay, which one am I going to use? 1 or 2? It depends on the information given on the graph. Okay, so you are going to use 1 or 2 to help you to find the function. Huh? Ian, Ayman. Ayman,
Yes.
which one are you going to use? 1 or 2?
2.
2. Why?
Because the information given in the graph can be easily placed in.
Yeah. What do you mean by can be easily placed in?
A substitute.
Substitute in what way? What are the information that the graph gives us?
The y-intercept, maximum point, and the
Yeah.
shape of the graph.
Yeah. So the y-intercept, and the most important thing is it gives us the coordinate of the maximum point. Correct? So we can straight away substitute in. So I straight away know this is my P, this is my Q. Agree with me? So I can straight away say, okay, my fx is equal to a x minus 3 squared plus 8. Okay, so how to find a then? Okay, how to find a? Is it possible for me to find a?
Yes.
Yes, how to do it? Xinyi,
Um,
There's one more information that we haven't used, correct, Shini?
The 5.
The 5. Okay, so how to put it? Can you? The 5 is the x or the y coordinate.
Y coordinate.
So what is the x coordinate for that point?
0.
0. So I'm supposed to put 0, 5. My fx is the y, okay? So 5 equal to a 0 minus 3 squared plus 8. So negative 3 is equal to 9a. So a will be equal to negative 1 over 3. So therefore, the function fx will be equal to negative 1/3 x minus 3 plus 8.
Square. X
Square.
minus 3 squared.
Yes, thank you. Are you okay? So can I use this one to find? Can, but the work will be more. It will be more troublesome, correct? You can try using the first one. You can try. You will get the same answer when you expand this. Okay. Got it? So whenever we do max, we have to take all this into consideration. Okay, before I go into cubic function, I just wish to describe the changes of the graph. Look at this part of the graph, huh? It means for x less than 3, how do you find the graph is changing? Is the steepness of the graph increase or decrease?
Decrease.
Decrease. But the value of y, is it increase or decrease?
Increase.
Increase. So we say y is increasing with the steepness is decreased, correct? With decreasing rate. So that is how we describe the changes of y, which is not linear. Got it? So for x less than 3. Okay, now, next point. At the point where x equal to 3, okay, the rate is 0. That means it stopped changing. Then after x equal to greater than 3, for x greater than 3, y is, okay, the value of y is bigger or smaller?
Smaller.
Smaller. So we say y is decreasing with what rate? The graph becomes steeper or less steep?
Increasing rate.
Yes, you are right. So you have to learn how to describe the changes according to the value of y and the slope of the graph. Are you clear? So this part is talking about rate is the gradient. We want to see how the gradient changes. Got it? So this is something that we are going to study in detail when we are in chapter 3. Okay?
Okay, okay.
Okay, okay. So if I give you a graph like that, how you describe? Just describe the changes only without the value of x. Okay, anyone? Chunyi, is it? Chunyi, can you try to describe this? Chunyi, are you in the class? No, you cannot say x equal to 1. I want you to describe the changes. This is y equal to fx, okay? Right? Remain unchanged? Why you say remain unchanged? Okay, so if this is my graph, how are you going to describe? What do you have remain unchanged? If y remain unchanged, the graph will go like that. Y is always 5. So this is called y equal to 5 is a constant. So we say y never change. So y is, so this one y is decreasing with, what is the rate? What is the slope? Is it become steeper or less steep? It become less steep, correct? So it's decreasing rate. Yeah. Okay. Okay. So tomorrow we are going to talk about another 2 polynomial. One is polynomial degree 3 cubic function. Okay, cubic function, we write it as y equal to ax cubed plus bx square plus cx plus d. And a cannot be 0, okay? If not, it won't be a cubic. Okay, now, if I give you a cubic function like this, y equal to 2x cubed plus 6x squared plus 13x minus 12. Okay, I say find the x-intercept. Do you know how to do this? So you just put y equal to 0. So can you get the value of x from your calculator? This one? Do you know how to use your calculator and get the value of x? This is a cubic equation. Okay, can someone give me the answer? It's exactly like you find your quadratic equation solution. So how many x-intercept this graph have? This function got?
3.
3. 3. Okay, let me tell you that for cubic function, correct? Maximum 3 x-intercept. So it means that you can have 2 only or you can have 1 only. Okay? And maximum 2 turning point. It can have 0 turning point also. So now, can you please key into the calculator and tell me what is the answer? Haha. So I got this from someone 0.670. And another one. Hello. You forgot what I tell you. When you put this one, when you have your x2 equal to negative 1.835, do you see there is a R up here? Do you see that?
Yeah.
So that means this answer is just tell you that this is the real part. So because for linear, for cubic, I can factorize as linear. And this is the quadratic. I mean, the linear one will be, I don't know, maybe it's x plus 1.835. And the quadratic here is without real root. So that's why here there is a R here. So this is not the solution. I told you solution must be real. So therefore, this one has only one x-intercept. And if you have a graphic calculator, I will teach you how to sketch a graph. The graph looks some sort like this. And the y-intercept is negative 12. So remember, for a cubic function, we can write it as a linear expression times by a quadratic expression. So this is about cubic. So tomorrow, I'm going to teach you how to write a cubic function as a product of a linear and a quadratic. Okay?
Yes.
So why I need to teach you that, I will explain to you tomorrow. Okay? So listen here, linear is power 1. A quadratic expression can be written as a product of 2 linear expressions. A cubic expression can be written as a product of 1 linear, 1 quadratic, or 3 linear expression. Okay, quadratic means power 4. So that is how we go. Okay, we only talk about until quadratic, okay? If you study in O-level, they will have such thing as called binomial expression. They will have higher than that. So that is not important. That one you can learn it by yourself. And it's not within our syllabus here. Okay? Got it? So that means for this graph, you have only one x-intercept. You get me? Hello?
Yes, yes.
Okay. So tomorrow, remember, please come for the class. Today, there are 3 persons didn't come for the class. Okay. Got it? So I will see you tomorrow. What time is your class tomorrow?
11 to 12.
11 to 12. Okay, I will see you then. Yeah. Okay, I will send you the link and I will see you at 11 to 12 tomorrow. Okay, thank you, class.
Thank
Thank you,
you.
teacher. Thank you,
Thank
teacher.
you, miss.
Thank you, teacher.
Bye, Miss.
Thank you, miss.
Yeah.
Thank you, miss.
Thank you,
Thank
miss.
you.